Hey everyone, welcome to my talk, Portal Internals. So, who am I? My name is Chris. I've been doing software development for roughly 9 years. The early years were mostly Java and JavaScript, building out web applications in kind of like React and maybe some Node backends. So I kind of learned a bunch of stuff there. But then I found Lisp and Scheme via SICP. And also the like YouTube lectures. So if you haven't seen those, they're actually really cool. And they kind of exposed me to a new way of thinking. And I really got into Lisp, but I kind of didn't know how to build software from them because I came from this ecosystem and this platform that I knew really well. And I was like, I wish I could put those things together. So because of that, I found Clojure, and it was like everything I wanted and more because it had immutability by default, which I didn't even know I wanted. So I kind of like got enthralled into the Clojure world. And I've been doing Clojure professionally for the last 4 years, and it's been pretty awesome. And of those 4 years, I've been working on Portal for about 3.5 of them, which is kind of wild to think. It's wild. Okay, so kind of what are my goals with this talk? The things I want to do are I want to talk about kind of what is Portal, not necessarily how to use Portal, but just like kind of some basic ideas of what it is, and then kind of how you can leverage it in different ways, and how people can potentially do different things with it in the future. So it's like motivating people to kind of explore, because I still think that we're kind of like still learning how to build software, right? So I think there's many different ways we like haven't even considered yet. So, but yes, I also want to look at some of the internals to kind of maybe you can encourage some contributions, and hopefully we'll learn some cool things about how Portal is built that maybe you'll be able to use for applications you work on or other visualizations that you might want to build. So those are kind of my like high-level goals. So roughly, what is Portal, right? So Portal is a data visualization tool. And usually when people hear data visualization, they think like charts and graphs, but kind of Portal is more targeted at like data structures, like sets, vectors, and like all the collection types. And kind of it pairs really well with TAP, which was added like relatively recently in Clojure 1.10. And the way I like to think of TAP is it's like println, but for data. And instead of sending strings to standard out, you send data to Portal. And it kind of, there's this like idea of preserving the data instead of serializing it as Eden usually as to standard out. And if you really want to get into like what is Portal, it's genuinely just a Clojure script application with a Ring backend and a reagent client. The cool thing about that though is that it is multi-platform, so the kind of like servers are written in Clojure script and Clojure CLR, and they kind of all get to reuse the same client. So kind of like a very basic description of what Portal is right here. But so if you've used Portal and you've kind of gone through the README, this is probably how you've interacted with it. You pull in the API namespace and you kind of open up an instance of Portal. You kind of wire together tap via add tap and Portal submit functions. So let's execute that. And then you kind of just start tapping values. So here we're going to tap two things, hello world and read string, right? So hello world is here, and then the read string was of the depths Eden. And right, you can kind of see like, oh, this is a map. It has these keys and these values. Those values, you can, again, collapse and expand them. You can visualize them. So for this view, I want to visualize it as a table. So there's a bunch of viewers that you can use for different values. And you can kind of see roughly what the depths Eden looks like. You can also remove tap, so you won't be able to tap anymore. And so I think there's some pros and cons to this usage of Portal. Like, it feels very easy to get going. You can kind of just start throwing data at this UI. Kind of behaves relatively reasonably, and that things are kind of added inverse chronologically, and that the things you tapped earlier kind of end up at the bottom, because browsers tend not to scroll, right? So you kind of just want to keep stuff at the top usually. So I would say it's like reasonable defaults. Some cons though with just adopting this right away is that you kind of just accumulate values indefinitely, because I don't think there's a good limit to know necessarily how many to accumulate, right? If I choose 101, someone wants 100, or sorry, if I choose 100, someone wants 101. So it's hard to know what good defaults are. And it's kind of like not particularly suited for any workflow. You're kind of just throwing data at it and not kind of getting the most out of the tool. So we're kind of going to look at kind of more things you can do with Portal in the later slides. Also, kind of you adopt the limitations imposed on you by tap as well. So I think some people might not be aware of, but when you call tap, I need to add tap again. I tapped this 100,000 times, but it only pulled, or it only actually got 100 or 1,000 because it has a dropping queue behind it. So kind of like there's all of these kind of default behaviors you're opting into, and you aren't necessarily aware of them all. So I just kind of wanted to show them all. Okay, so once people start getting used to Portal and they kind of get used to the different visualizations, they kind of have this insight of being like, I want to be able to set a default viewer. So let's go over here and talk about this question, right? Hey, how do I configure a default viewer for my value? I think the issue, or I think that question has a couple sub questions as well, which is like when you want to set a default viewer, there's like a value, right? And there's a mapping between that value and a viewer. So there's a mapping, right? And how do you specify a mapping in Clojure? There's like probably two good ways. There's like maps and code. The issue with maps is it's kind of hard to put everything into a bucket. So you probably don't want to do that. We could do code. But with code, like where does it execute? Does it execute on the client? Does it execute on the server? There's like a bunch of sub questions, right, that get answered, that get asked. So Portal's approach is to be like, let's just wait off on that, or let's just hold off on those questions. And instead, let's establish like an information model of like, how do you represent a default viewer in data? And for Portal specifically, I chose metadata to be like, hey, for this value, I want to use this as the default viewer. And then these other questions don't kind of matter as much because it's at some point in time, someone can put some metadata on this value to set the default viewer and kind of all the questions go away. There's some caveats with metadata that people might not be aware of, which is that not every value supports metadata. I kind of made that a little bit easier by adding this Portal viewer namespace recently. It kind of makes that not as big of a problem, but that is something to be aware of if you are trying to do it more manually. So yeah, let's take a look at the implementation really quickly. So here's kind of a mapping of kind of what I just described, which is for strings, I want to use the text viewer. For bytes, I want to use the binary viewer. And for everything else, that's what you can see in kind of this sum, I want to use the tree viewer. So what's really cool is like this is completely arbitrary. And let's execute that. And let's open up an instance of Portal that now has that as the like custom submit function. And so that's kind of the like trick here is that you don't have to give Portal the value directly. Like when you call psubmit, you're kind of handing the value to Portal. You could do some other stuff first, right? You could do arbitrary transformations. So in this example, we're kind of setting the default viewer using an arbitrary dispatch function to say, use this viewer for these values. And so now when I submit these, you can see for the text value, I got the text viewer right here. For the binary value, I got the binary viewer. And for everything else, I got a tree viewer. So this isn't super obvious, but it's really powerful because it lets you kind of do all types of things that kind of you don't even need to concern yourself with Portal necessarily, with Portal's internals necessarily, but still get a lot of leverage out of customizing how you interact with Portal. And again, like these are kind of tricky with metadata, but if you use this Portal viewer namespace, it kind of papers over a lot of that. And at the end of the day, it's just wrapping things with things that do support metadata. Okay. So that's one way of using it, like a custom submit function. Let's take a look at another way. So I talked about tap and it being added in Clojure 110. Alongside it was the protocol Datafy, and kind of it's a really cool protocol in that it's given an object which tend to be opaque and like hard to like introspect on, turn it into data. And so I think by default I used to have it on, but it used to be having on by default makes it hard to opt out. So what I settled on was you can opt in instead. And it's very easy to opt in because you have the ability to do custom submit functions, right? So here's kind of what that looks like. You you define your own submit function here, and it's just a composition of Datafy and submit, right? This is really simple, I think. And then you can start tapping objects that are datafied by default now. So here's an example of looking at the Clojure core namespace. You can see all the public functions it exposes. all the vars it has, right? And so this too is the datafication protocol that was implemented in Clojure core itself. You might have other datafication implementations, but and then here's another one for classes, actually. So here's the datafication for the long class. You can see that here are all the like member things, and you can put those in a table and see that all the reflection introspection data that you could ever want from the JVM for a given class type. Right, so it's relatively easy to opt in, and I like that behavior is like make it easy to opt in, but don't have it on necessarily by default. So another example of kind of this custom submit function is for not necessarily just transformations directly, but like transformations over time. So if you've worked with asynchronous values, like promises, kind of what I've seen people is like they don't necessarily know that they have a promise, and they call print, and they kind of see something like this where it just says, "Hey, I'm a promise," which is like I'm trying to debug this asynchronous program, which is already difficult, and I have to worry about wrapping the things I'm printing so I can actually see what my program is doing. So it's kind of easy to kind of remove that cognitive load on yourself by using a custom submit function that here, let me close this. Here you can see it's just always asking the question, is the value that I'm tapping a promise? If it is, okay, let me wait on it really quickly. So here I'm gonna do that where I'm gonna tap a promise, and I'm gonna wait the 5 seconds. And what'll happen is if the value hasn't been delivered to that promise, it'll just say timeout. And like, again, this is completely user specified. So maybe you want to do some other things instead. You want to tap another value. You want to go look somewhere else, right? This is completely arbitrary. And if I do it again, and this time it just so happens that the value is delivered in time, I can tap that instead and kind of continue my debugging process. So I think there's like a ton of power in having these like arbitrary submit functions is what I call them. It's not really an official name, right? But that's what I call them. And then you can do all types of things. You can do transformations, wait on things. The other thing you can do is kind of like break things apart. Like maybe you got a big value and you're like, I know this shape and I don't want all of it. I want parts of it, so I can submit A, B, and not C, or I can do like arbitrary things. I feel like it's really powerful, and kind of people can do a lot of interesting things here. So the other thing you can do too is that if you kind of maybe get sick of wrapping your code in taps, but you still want to utilize all the advantages of being able to kind of like send data to Portal, there's this Portal nREPL middleware that will kind of do a lot of that for you. And when you evaluate code, so this is actually probably one of the primary ways I use Portal, and that I'm just sitting at the like in my code editor, just evaluating expressions, and kind of magically in my Portal, I get all these values. So I saved this session I had earlier into a Eden file, and I'm kind of going to load it up really quickly of kind of what the nREPL middleware produced. And it kind of captures source information. Let me kind of expand all these. It captured source information. It captured runtime information. It captured how long the thing took, when it happened. Some other cool things is it captured like standard IO. So like this println produced some stuff to standard output, so we can also capture that. And it gives you like the datafied representation here. For tests, it's actually really nice whenever Clojure.test/report generates output, the nREPL tooling can kind of grab that and kind of accumulate that data and then just plops it into Portal. And Portal knows that, hey, that looks like Clojure test output. Let me render it like a test. So you can see kind of here all the tests that were evaluated by running this code right here. And you can then dig into that and see like here are the assertions. And I don't know, I find this to be really nice to be able to quickly dial in on what's wrong, what happened. I had this, I expected this, it's not quite it. And I think this is particularly nice for when you're sorting on larger values. Like if you have this big map and this big map, and you're trying to check if they're equal, and it blows up, and you kind of don't necessarily know why. You being able to see just the data itself in a nicely formatted way is, I think, super, super cool. It'll also, one of the things that I think happens when you wrap your code in tap is if exceptions are thrown along the way, your value will never make it to Portal, and you'll kind of be confused. You'll be like, what happened? So by using this, it'll try catch all your evaluations, and any of those exceptions will kind of just find their way into Portal, and you'll be able to kind of be like, oh, the thing I tried to do didn't work, and here's why. And because this nREPL middleware uses tap underneath, you can still leverage all the knowledge of, or all the like stuff you did before with custom submit functions here, right? Because nREPL will produce a value. That value will get sent to your custom submit function. That submit function can do things like, maybe you don't like this data structure, like maybe there's too much information here. You can pick away the pieces and submit parts of them. You can do whatever you want, right? Maybe you persist them to a file by default, so you have it as a persistent log for future things. I don't know, right? I think everyone kind of works a little differently and kind of has different priorities. So kind of being flexible in that way, I think, is a good thing. So now that we've kind of seen different ways that you can use Portal, I kind of want to get into like more of the nuts and bolts. So we're going to implement our own submit function independent of Portal's submit function. So here's kind of an example of what that looks like right here. I'm going to define an atom with a vector, and my submit function will just put things, will conj things into that vector, and then I'll just say, hey, add tap submit. And I'll, even before opening Portal, I can start tapping values, right? And then later on down the road, I'll be like, hey, Portal, can you inspect this tap list? And what you'll see is it kind of opened up an instance of Portal with that value as the value you're inspecting. And so like if we continue tapping values, it'll like end up in that vector, and then Portal will see that it ended up in that vector and it'll update the UI. And I feel like this is where maybe people start to realize is that like tap isn't, like Portal really only cares about data and atoms, and that's about it. So at any point in time, if you want to view data or if you want to view atoms, you just say, hey, Portal, view, let me view this thing, and it's like, cool. And then on top of that, something that I think people don't necessarily realize right away is that you can open up multiple instances of Portal. So here's an example where we have two instances, one here, and I continue to tap and they both get it, right? Because both instances are watching the same atom. And you can open up completely like different instances that have nothing to do with previous instances at all. So here, I want to open up an instance of Portal that looks at my BB Eden, which is an Eden file that I can read string in, and just look at that, and completely independently, right? So kind of Portal doesn't necessarily care about how you get your data to it. It just cares about the data itself, and atoms in particular are a type that it cares about because it knows how to watch them. So I want to kind of get into like that a little bit. Like, how does Portal know about, or how does Portal work with atoms, right? I kind of want to use Portal to introspect on the internal state of Portal itself, right? Because like I mentioned earlier, Portal is just a Clojure application, so we should be able to debug it like any other Clojure application, right? So there's this mode that exists that you don't necessarily have access to as a user. So you won't be able to do this locally, but I can still demonstrate kind of what the internals look like. So here what we have is we have two instances of Portal. We have an instance that you usually interact with, and then this instance is actually viewing the data structures and atoms for this instance. So it's kind of like saying, hey, can you tell me about that one? And so we can kind of see like all the things that it would care about, all the sessions that have been currently set up, all the connections that it has set up, all the commands that have been registered. And then specifically, you can see like its session state. You can see things like what's the session ID, what are the options that were passed in. And by the way, a lot of these are, it's kind of hard to see, like atoms themselves, right? So we're seeing not only the state, but the live state for that value. Sorry, for that instance. So for example, if we focus in on this value cache, what we'll see here is when we submit these two values to Portal directly, you'll see that it captures those values in this list, right here. And it captures two things. It'll capture the actual data for it, but it'll actually capture the atom as well. And kind of that's how it can be, that's how it can communicate back and forth, like the exact instances of the objects that you've kind of sent to it, because it knows about, it keeps track of everything that it's seen. And what you can kind of see here in this value cache is it's a bidirectional mapping, where the keys on the left represent an ID or a value. And so you can give this map an ID, like here, you can give it the ID 6 and it'll give you this atom. Or you can give it this atom, and let's try to figure out which one it is. It's not this one. Is it this one? No, let's keep going. It's probably this one. Oh yeah, I don't know why I didn't think that. So it's bidirectional. So when I give it the ID 6, it'll give me the atom. And if I give it the value of the atom, it'll give me the ID 6. So right, when the client and the server are communicating, they can just communicate some IDs if the values have already been like communicated. And so this is one of, I think, the really cool patterns that I like about having like immutable data structures in Clojure, is that you can do composite keys in your maps, and everything just kind of works. It's really cool how you can have equality as like a fundamental part of your language. And it's something that I leverage here, and I leverage it in a couple other places. And I think it's, I mean, I don't want to say it's underutilized, but I don't see it used a lot. And I really like this pattern of having composite keys to kind of index stuff. So that's a value cache, right? So every value you send to Portal, it will like put in this map, and it'll try to communicate that value to the client in as high a fidelity way as possible. Sometimes it can't, so it'll just like keep a pointer to it and print string it or whatever, right? And the other thing too that this allows, this value cache, is that if I've sent you the value, I can just send you the ID, which is like a form of compression, which I feel like is handy for when you repeatedly tap similar values, like when they have a large subset of the same stuff, you don't need to communicate that again and again. So for me, this happens a lot for UI applications, where I'm kind of like spamming the state, like what is the state, what is the state, what is the state? Most of it's unchanged, and that doesn't cause your portal to crash. And it's because of this value cache. And then the second thing outside of the value cache, if we go back, is this watch registry. So the watch registry, it's part of your SHSIM state, and it's an atom of a set that contains atoms that portal is watching. And so this is it, right? It just says, hey, here are all the atoms I found in the data you gave me. I'm going to keep track of them. I'm gonna watch them, and when they change, I'm going to let the client know, which we'll like get into the specifics of that a little bit. But the cool thing is, like, this all composes, right? Like, you can put atom. I mean, it's not necessarily a good architectural pattern to put atoms and atoms, but you technically can. So here, I'm going to submit an atom into the tap list, which itself is an atom, and then I'll be able to, right? This instance has that atom, and this instance of Portal introspecting on this instance has the atom. I know it's getting a little kind of hairy, but like it all makes sense, I think, because if I start swapping the value, right, everything stays up to date because they're all kind of watching the same atom. So that's kind of like at a fundamental level how Portal inspects values. It kind of like tries to pick everything apart, and when it finds an atom, it'll watch it. And when it finds collections, it'll put them in this value cache to kind of remember that. And this is particularly useful for objects. And the really cool thing here is like this is just the public API of atoms, right? Add watch is a function, and I don't know if people use this a lot in the normal application development process, but it's just a function that exists in Clojure core. It's not platform specific, so a lot of the implementations of Clojure have this like available. So this is the actual code in Portal that will watch the atoms, right? It exists for Clojure, Clojure script, and Clojure CLR. It just says, hey, for this value, has it changed? And then the only thing that happens when an atom changes is it'll let the client know. It'll just ping it to be like, hey, this atom changed. It's not going to send the entire value because it's up to the client to figure out whether or not it wants to pull the value for that atom. But yeah, I feel like the Clojure state model of like values versus state has kind of made the implementation for Portal way easier, because I'm either always dealing with a value or I'm dealing with an atom that will point to a value, and that's it. I can eagerly serialize values because I know they won't change, so I just send them to the client, and then the client can be like, cool, I have the value, I'm going to, and like I said earlier, it's a reagent application. The reagent code in the portal client doesn't care how the data got to it. It just says, I have a map, I have a list, I have a vector. I'm going to render it this way or that way or that way. So it's kind of like, it doesn't care, which is awesome. But there are some, like, I guess, implications. And so, like I mentioned, metadata was a way to configure things previously. The issue with that is that when you kind of update data and you only update the metadata, it won't trigger this code. So if you're kind of there trying to like change the metadata of your value, and you're like, why isn't portal updating? It's because it's using equality to like prevent sending the same like update twice to the client. So yeah, this is kind of like the nuts and bolts of how the portal inspector looks at your atoms. And everything else is just data that gets serialized and sent to the client. So we can take a look at the client state, which is like the other end of this, right? We like inspected the server state, but likewise, the reagent application has state as well that we can take a look at. And so here's that, where before we saw portal client, here we're seeing portal, we saw portal server, here we're seeing portal client. And you can see that the things that I care about from the perspective of the client is whether something is expanded, whether or not there's a next state. So let me get some data into portal. So for this value, hello world, when I select it, it will kind of go into this selected vector. Let me just click that. Okay, so it'll go into this selected vector, and that kind of vector has the context of where that value is. Because I think if all I did was say, hey, you've selected world, the issue is that there are many potential worlds in a list, right? You could have tapped this multiple times, like here, right? I actually want this world, because it might be different potentially. So you like can't just capture the value, you kind of have to capture the context of that value. So, and it's really easy to see that. You're like, okay, this is the context. It captures what collection that value was found in, how deep that value was found. I think key is like the index 0, 1, 2, 3, 4, right? Yeah, it's the fourth index. What the parent context is itself. So if you kind of want to walk up the parents to do other things, you can. Right, but all this is like easy to see in the portal viewer itself, inspecting the portal state. So it's kind of a little meta, right? So another thing that is interesting about how the client works is there is a log that I keep track of for all the RPC that happens. Because so I mentioned earlier that it's a ring server, reagent, client, and they're kind of talking like you would expect via WebSockets probably. And there's an RPC layer, and you can kind of very quickly see what are the RPC requests that are being made. So let me clear the RPC logs. So we'll like start fresh. I'm going to click this value. Okay, and when that happens, these two RPC requests go out. The first one is update selected, and kind of that's how the client keeps in sync with the server. It's just anytime you select something, it says, hey server, this is selected or that's selected. And so if you've ever used the functionality in Portal where you can get the selected value back in your REPL, this is how it works. It's every time you kind of change what you have selected, the client will notify the server, and the server will be like, okay, cool, I have that. And likewise, for that value, we'll get the functions that are allowed to be run on that value. Because like the functions you specify can have predicates on them. So that's what you're seeing here, is like we're saying, hey, get functions. Here are the arguments, the keyword hello. And then it's going to give us this table of like, and which is, actually, let's preprint this. If we preprint it, you can just see it's a list of maps, right? Active table, and so it's very easy to kind of introspect on the state and kind of what's happening if you kind of just datafy everything. Yeah. So let's go back really quickly. So the other things that are kind of interesting in the UI's implementation is this concept of a selection index. So when you're kind of in the UI and you're kind of using your arrow keys to kind of go left and right, up and down, that actually is kind of a little difficult. And the reason why it's difficult is you have to like have relative view of the world. And so when the values get rendered, kind of there's this other data structure that gets built up, which is, again, another example of kind of having composite keys in a map, is this concept of a selection index. And it'll capture, again, a bidirectional mapping where the things on the left are where a thing is and what it is, and what a thing is and where it is, which is kind of a mouthful, but let's put this in a table. Let's open this up, right? So we've seen the context before. So what this is saying is that at this position in the UI, right, column 0, row 0, and then it's nested, right? Because you can kind of have nested tables, is this context. And then likewise, you can find a context and it has a mapping of it to a position. So this is kind of what powers a lot of this relative selection, which is like, it's much easier just to see it as a data structure. Oh yeah, like I could write the code that like looks into this data structure given this context and pulls out this position. And likewise, if I had this and I wanted to find things that are adjacent to it, I pop the last element, right, and I look for the column to the right or the row above or below, right, based on the directionality of the keys. It's really easy to kind of index this data with relative positions. So yeah, so I think this is like a good way of kind of seeing how an application works. Like the specifics here might not be like super important, like, oh, there's a selection index, but I do feel like this is like a learning how to debug this is, I think, interesting, right? Where you can literally just see the underlying data structures. And I think a lot of people, if you just hand them the data, they can kind of visualize the code. So let's move on from this. And I kind of want to like talk about how other people in the community have leveraged Portal in their workflows in kind of different ways. So recently someone on the Portal Slack posted some some code that they wrote around Portal around formatting their test output, right? They were like, I want my test output to be a little different. And it wasn't a ton of work for them to get that working, right? They were like, they were able to leverage, which we haven't gone into, but they were able to leverage the Hiccup viewer to kind of format their data the way they wanted. So this is kind of like another level. Let's see, this is the tree viewer. This is like another level of customization, is that there's this viewer called the Hiccup viewer that kind of just lets you throw Hiccup at Portal and it'll be like, cool, I know how to turn that into HTML and render it. Right, because there's like divs, there's CSS here. There is one trick, which is that you can nest Portal viewers in Hiccup, which is kind of lets you go like from Portal to Hiccup back into Portal. And again, you can recurse because like HTML is recursive. It makes sense for you to be able to recurse in and out of it. But I really like this type of customization because it kind of is relatively quick. Like there's no UI code here, right? There's some code on the back end where the tests were ran that kind of formats this into Hiccup and then throws it at Portal. And then it let's see, I think it does. Yeah, it puts the metadata that I was describing before on it that just says, hey, this is Hiccup. And Portal's like, cool, this is Hiccup. And what's really cool is that reagent components essentially return Hiccup. So like there's a upgrade path to kind of more interactive viewers if you wanted to kind of invest the time and effort in both learning and like polishing. You like can progressively build out custom viewers for Portal itself. And so let's go on to, so another example of someone in the community kind of taking an existing tool and kind of leveraging Portal is this playback library, where you can pull it in and start tracing functions. And I think it's using some existing libraries, right? But it kind of takes the output of the library and kind of funnels it into Portal and kind of makes it it leverages the viewers that are in Portal, which is, I think, kind of cool because it's like people exploring kind of different ways to kind of develop code and kind of, yeah. Sorry. But yeah, I love this type of experimentation of kind of throwing stuff into Portal and seeing what you can make sense. So like a really cool thing that someone did recently was they took this project called Emmy Viewers, which I think was initially developed to kind of visualize some algebra. I think it's a computer algebra system called Emmy, and there are viewers for it. And I think they were initially developed for Clerk. And I would say this is a much deeper integration into Portal, in that it will load a ton of NPM dependencies. Well, not a ton, but more than the previous examples, where it'll load code from NPM, and it'll pull in some. I think this one uses. This one uses MathLive to render stuff as LaTeX. Right, so it's like taking stuff from NPM, taking some Clojure script in, rendering it. And so here's an example with a chart where you can kind of see this function rendered using this visualization. And I think the like cool thing here is like this was developed in mind with other tools, but they were able to kind of port it over because like, we're all kind of in the Clojure world using Reagent. We're all using Clojure script. So it's kind of like very easily, right, to kind of hopefully make these things work in multiple places at the same time. Let's see what comes next. So personally, kind of one of the ways that I like to use Portal is I like to use it for the build output for Portal. In that, let's just run this. So I'm going to run the default Portal build, and you'll kind of see that it's like it's like just standard output, right? These are things that you would see like in your GitHub Actions logs, right? Just a bunch of standard output. So while that's running, I'm going to run actually, can I run them concurrently? I should probably wait until this is done. I don't know if I could run two builds at the same time. But you can see, right, it's just dumping stuff to standard output. By the way, this viewer, right, this prepl viewer is the one I demoed earlier that was kind of inside the nREPL viewer. Or not in the nREPL, inside the log viewer in nREPL, because it, like, at that point, the log viewer was driving, and inside of it was the prepl viewer. But there's nothing that says, like, that data has to be on the outside. You can take the prepl viewer and put it on the outside and put the log viewer on the inside, right? So like another thing with these viewers is they tend to be composable, right? In the same way that data is composable, these viewers tend to be composable. So let's see, right? You'll see like ASCII formatted tables using Clojure's table formatting facilities. And you'll see like, right, this is all standard output. This is standard error. That's kind of, because there's a distinction, right, between standard output and standard error. I think this is just because the tool decided to output stuff to standard error. There's more tables. So here you can also see there's test output. So there's like a couple things happening. There's like a node build that's running tests and then running this performance benchmark. And it's running it in different versions of Clojure script. It's running it in, it's running some UI tests in Node as well, actually. And then it runs it in Clojure, and it runs it in Badahdah. So that's like what you would see in the, oh, I forgot that I added it to Clojure CLI. It also ran it for Clojure CLI. I don't think that runs on CI by default. Oh yeah, because I did that. But so it ran all these things for all these platforms and kind of outputted it. The issue, right, like this, it's like hard to get at this data. Like if I wanted to take this and kind of take this somewhere and do something with it, I kind of can't because it's been stringified, which is like the core problem, right, that Portal's aimed at solving. So maybe instead of just outputting this, we could output the data interlaced with the standard error instead of output where it makes sense. So the first one we'll kind of see, I think I left this in on purpose. Yeah, here we go. So prepl can have embedded in it the log viewer, right? Because I wanted to be able to like take the CLJ Condo output and format it as a log. Like, why not? That makes sense. There's usually a file and a message and like all this stuff. So like here's the embedding happening the opposite way. Likewise, all the tables are tables now, right? So this table right here can be visualized using the table viewer that I kind of demonstrated a while ago, which is nice because it's data. So if I wanted to copy paste it, I wanted to do stuff with it, like select columns, like all those things are available to me because I preserved the output as data. And then the really cool thing is this test output. So earlier, I kind of demoed nRPL, where you can run the test interactively, and you can leverage this viewer. Here, we're leveraging this viewer, except for the process that spawned these tests is now gone, right? But it produced the same type of output. Portal was able to capture it and keep it as data, and then visualize it as test output. So we'll be able to see the same thing, right? Where we can see all the assertions. We can see, what they were, like 1 is equal to 1. A lot of these are sanity tests, right? For this one, but what about? I think the ones we looked at specifically were CSON. Or I think it was this one. I can't remember which test we looked at earlier, but right, you can leverage these viewers independently of where the data came from, I think is the thing I'm trying to point out. And then a really cool thing is that on top of all of this, the one problem I've had with build outputs in the past is that if you do them in parallel, the interlacing kind of doesn't make sense. You have this part of the build for this thread and that part of the build for that thread, and it kind of gets all messed up. So if it's data, you can just kind of build up the data structure that is independent of order of execution and just keep it all in line. So here's an example of doing better than what you can do with standard output, which is building the same linear output that you would expect, but building it in parallel, because you have access to the data structure and you can just build up sub vectors. And it's much faster, actually. Let's take a look. So this build took, if I look at the metadata, I did this recently where I could stash in the metadata. This one. Yeah, so this took 54 seconds, and then the parallel one took 20 seconds, right? It makes sense, because parallelization, if you can run them all at the same time, you can. So I think that this is kind of one of the workflows I like to use Portal for, is doing the same thing, kind of enhancing output with a little bit of data, and then ideally being able to get more out of it here, which is parallelization. And you can kind of see how this works in that it's capturing all of the standard outputs of those sub processes independently. So here's the first one and the second one and the third one, right? It's this is, I would say, kind of trivial to implement, and that I know how to concatenate this series of vectors at the end. It's like a map cat, right? So I feel these are the kind of workflows that I hope Portal enables others to kind of explore and play with. So I mentioned CSON, and this is another cool visualization that I worked on recently, where I wanted to. So I guess we can talk about what CSON is. So Portal uses a custom serialization format called CSON. It's mostly like Transit. It kind of grew out of needing to make sure that this always worked. And the thing about being a library is that you can't always be in charge of transitive dependencies. Because you don't build the class path, your user does. So they might bring in an older version of a library that you're using that doesn't have the features that you need. And so for serialization, for Portal, it's super important. So I couldn't kind of have that flexibility of letting the user specify it. And also you inherit their bugs, right? So if they have this bug that most of the time doesn't affect most people, but for you it does affect you all the time, you can't kind of reprioritize their priorities, right? So I kind of was okay, I'll do a custom serialization format, but the issue with that is now performance is a problem, right? I have to make sure that it's at least as good, right? And so that's kind of what we saw on the last slide, is that table was the benchmarking for that serialization format. But it's just a table. It's kind of not the best way to view it. I kind of this is the one instance where having charts and plots is kind of nice. And so those are baked into Portal via Vega and Vega Lite. And the cool thing about Vega and Vega Lite is they're not specific to Portal, right? They're you go on the internet and you look at the tutorials that people have built or the documentation site, and you copy some JSON and you paste it into Portal, and you just keep iterating on that data structure. So this is kind of what the data looks like from this standard output. And here's kind of what it looks like when I've kind of processed it a little bit to produce Vega output. So let's take a look at what that kind of looks like through the inspector. All right, it's just a map, all right? Everything's data. It's just a map. It has the specific values for this data set that I was encoding, because that's what we're kind of seeing here, is that for a variety of input data, like how does this custom serialization format work with Eden? Because like Eden is another alternative to Transit as well. So I kind of wanted to quickly compare all these different serialization formats against each other, kind of see. So because like if I want to improve the performance, I kind of want to know, do I focus on this type of input or that type of input? And I'm not saying this is how you should do performance analysis, but this is just kind of what I've found to be useful, right? But like this, the cool thing here is it's just Vega Lite. It looks like this. You can kind of see for these different data structure input values, that's what the labels are. So like if we go back over to, let's do hiccup data. We go back to the inspector, and I put some metadata on here. So this is the literal value that's being serialized and deserialized for this benchmark. It's like take this data and just keep doing the thing, and let's see how fast it works. And so I did that for all these specific examples, and then I put everything together and just said, okay, how does it overall, if everything's together, how does that work? And I think there's some interesting results here. I think I would have expected there to be like a dominance one way or the other, but it's like they actually trade punches. Like sometimes Eden can be fast, sometimes it can be slow. So I don't know. I think this is just interesting, and I kind of it's easier to see that by building out this visualization. The other advantage, by the way, of having a customization format is that it is CLJC, which means that the serialization format kind of works out of the box for Clojure, ClojureScript, and Clojure CLR, which is, I think, really cool. Because it made my port to the Clojure CLR, like building out the server for the Clojure CLR, much easier, because the serialization format is just a CLJC file. So that's like another cool usage. Okay, now this one is just to kind of show how cool SCI is. So when I first got into Clojure and ClojureScript, I kind of built out this Tetris application, and I wanted to know if it would work via SCI in Portal, because like Portal's using SCI for extensibility. And so here's like an example of running this application, right? That I didn't really change it to work in Portal. It's just that reagents, like unchanged SCI, supports a large subset of ClojureScript. So kind of again, all this stuff just kind of works together. And I have my Tetris implementation just working, and it's surprisingly fast. Like I was like, oh, for an interpreter implementation, like this is wild. Like I couldn't tell you the difference between this and my the one that's built and deployed as compiled ClojureScript. So yeah, it's kind of wild how good this is. But this is kind of the like engine underneath if you wanted to get into the UI extensibility, right? Because as I was talking about, you can take Hiccup, and I didn't demo it, but there's documentation, right? You can start from Hiccup, get a nice view that you like just without even touching the UI. And then eventually, when you're ready, you can start shipping ClojureScript to the client. And it's pretty performant. It's pretty cool. Okay, so I've covered a lot of things. There are more things. There's always more things. There is documentation. It's kind of at the end of last year, this was added. So it's not, I don't think a lot of people know about it who kind of came into Portal like before then, because they may have missed it since then. But yeah, you require in the Portal API namespace, you do pdocs, and it'll open up in the cool thing here is it'll take the static markdown that exists in the documentation that's deployed to Clojures and kind of enhance it with the viewer documentation that kind of can only run in Portal because you need access to the viewers. Right? So here's like the README, here's like, some other articles and guides, but then under viewers, you can kind of see all the viewer guides or all the viewer docs where you can see like the name of the viewer, kind of like all the things that are over here that I've been talking about. The name of the viewer, a quick doc string, the spec that the viewer uses to match the data to see whether or not it's applicable, which is kind of really handy for debugging why the value you're producing isn't being used for that viewer, right? So you can see all the viewers. There's like a handful here, or not a handful, but quite a few handfuls, right? So we have the exception viewer, the log viewer, HTTP viewer. This one kind of doesn't do a bunch except for kind of give you like a, hey, this is an HTTP request. You might be interested in this when you're kind of seeing your output from your portal. It kind of just puts it in this bucket. Image viewer, let's see, what are some of them? The test view that we've kind of gone over. Here's kind of how it knows that the output that's being produced is test output. Here's this Clojure spec that says, hey, I expect this shape. And when I do, I know it's test output and I can do stuff to format it like this. The PREPL one, which is what I demoed previously, right? Whereas like you have, let's see, it's a collection of maps. It has to be at least have one, has a tag and a val, and the tags are out, error, tap, and return. So that's it. Color viewer. Anyway, there's like a, if you wanted to kind of see more of what's available to you in Portal in terms of viewers, highly recommend this. Go through it. If you find something lacking, we can definitely, improve it. Like it's documentation is an ever growing thing, right? You keep having to do more and more of it. And I think it's one of those things that you don't know what you need to document until kind of people start having those questions. So I kind of don't necessarily know what to put in until people start asking questions. So, and one of the things I've been thinking about is it kind of be cool to kind of do this generically, because currently this is kind of specific to Portal. But kind of I see a future where this could be generic and people could pull in guides for libraries and start running through an interactive guide and kind of executing code and seeing what happens without even need to fire up REPL. Well, I guess they'd need to fire up the doc view somehow. But after they do that, right, they can start just evaluating code and just start learning kind of what this thing does. So let's see, some current limitations that I kind of didn't cover but exist. And this is just to be aware of because you might run into them. The serialization is eager, right? So if you have an infinite value, I'm just going to try to serialize it infinitely. It's hard to know if a value is large or infinite, right? If you are working with infinite data, you have a custom submit function that you can use to truncate it and maybe nav it so that you like point around to it. So it's definitely easy to solve this problem. And then another thing I actually encountered recently is that streaming isn't serialized. Sorry, serialization isn't streaming. So kind of you have to fit everything in memory for your data, and then you have to fit the serialized representation, and then you can. So you have to fit both in memory, which is kind of a limitation. Something that might get fixed in the future. Because this is a Clojure script application and a reagent application, like any of the data types that are weird in Clojure script relative to other platforms continue to be weird. So longs aren't fully supported, so they kind of have to be boxed into strings after they get to a certain range. Dates are the same way, and then I think the calendar is a lot different. Just weird, quirky stuff you might run into. One thing I ran into really recently is, right, we're just conjuring onto a list when you call submit. The problem with that is then you can put in a lazy seek into that, and if that lazy seek throws an exception, kind of suddenly all of the internals of Portal become broken. So I had to add like a like a pre-filter to prevent kind of lazy seeks from blowing up the internals of Portal. But it kind of can only do so much. So if you are kind of inspecting your own atoms and you put in bad values, like Portal won't protect you from that. It'll just protect you from when you use the Portal submit function. So yeah, there's some other like stuff that's happening with like some garbage collection. It's not perfect. It kind of does exist, right? Because once you start accumulating values in that value cache, kind of when the client is done with them, it'd be nice to know for the server if they can just release it from the value cache. So there's some stuff around there that kind of could be improved. Future goals, I think simplifying extensibility. I've kind of talked about it a little bit. There are a ton of guides if you want to like dig into that rabbit hole. But I still think one of the fundamental problems of extensibility is like, cool, you built this thing and now you want to share it. It's surprisingly difficult because there's a lot of things when you're building out like UI stuff. There's like packaging. So like the Clojure script code itself, do you ship it built? Do you ship it source? The dependencies, where are they from? Are they NPM? If they're from NPM, are they, this format or that format? There's like a bunch of, I want to say, ecosystem problems that exist here that kind of I want to make it easier to share these visualizations because like I think there's a bunch of cool stuff we can share. Yeah, I want to continue to explore, document, and enable more workflows because I think we can still do more cool stuff. User-defined keyboard shortcuts, I think that's like one that people have wanted. I just haven't gotten to it. So, and so there's probably more goals, but these are kind of like quickly what came to mind. But yeah, so everyone works a little differently. Kind of Portal wants to be available for people who work differently. And the way you can customize Portal, again, it's not obvious how you can customize it, but once you kind of learn some of the tricks, you can do a lot of things. So, and I think you get the most out of Portal when you do kind of invest a little bit of time to kind of make the experience suited for you, because you'll be really happy. Like, this does exactly what I want. And I think there's like a theme here too for me that I've like latched onto, which is like the more you datafy your workflow, the more you get out of Portal. And like any data visualization tool, but just like instead of like, you know, streaming stuff to standard air and standard out as like as strings, keep it as data, and you'll have a better experience with these data visualization tools. So yeah, that's it for me. Thanks everyone for coming to my talk. Thanks everyone who's contributed to Portal, both questions, code, everything. It's really awesome to see the community kind of like do cool things with this. So thanks everybody. And then also if you kind of like the work that I do, and you kind of want to support me, I do have GitHub sponsor set up. So yeah, thanks.